So as we now start to look at natural language processing, particularly with neural class models, one of the key concepts that we're going to repeatedly utilize is this concept of word vectors. So what this means is that every word in our vocabulary is going to be mapped to a vector. And then we will do our analysis of natural language in the context of these word vectors. This is a fairly novel and perhaps unusual concept. And so before we dive too deep into the natural language processing, I think it would be worthwhile to spend a little time just to get some deeper preparation or understanding for what we mean by word vectors. So to try to understand this, let's just think about a map of the globe. And so what I'm showing on this map are several different symbols, squares, triangles, etc. And the thing that I want to communicate through those symbols is the idea that if 2 points on the globe or on this map are physically nearby each other, so if 2 points on the globe are nearby each other, we would expect that the characteristics of the associated regions are similar. So for example, you see the triangles in South America are near each other, where the squares near Asia are near each other. And so the idea is that the regions characterized by the 2 triangles, since they are physically near each other, we would expect that the characteristics of perhaps the people, the geography, the history, etc., of the 2 triangles would be similar to each other, and the squares, since they are physically proximate, would be similar to each other, but very different from the regions characterized by the triangles. And so the concept here is that we can think about the globe as a breakdown into longitude and latitude, 2 numbers, longitude and latitude. So we can think about this as a 2-dimensional space. If 2 points in that space have similar longitude and latitude, we would expect that those regions on the globe are similar. If the associated longitude and latitude of 2 points is very different, we would expect those regions to be different. So we have a concept of similarity manifested through proximity. And so the way that we could think of this is that we're going to do a similar type of concept with words. So every word in our vocabulary is going to be mapped to a point in a 2D space. And that the closer 2 words are in that mapping or in that 2-dimensional space, the more related or synonymous we would think the words are. The further apart 2 words are in this 2D space, the more dissimilar we would expect the words to be. And so conceptually, this is purely conceptually, we could think of a situation where we have a vocabulary of V words. So we have word 1, word 2, word 3, all the way up to word V. And then we can think about mapping every word to a 2-dimensional space in longitude and latitude, or long and lat, analogous to the way that we were thinking about the globe. And so the way that we would like to do this is that we would like to learn these 2-dimensional vectors of the words in such a way that if 2 words are similar or synonymous or related to each other, we would want their associated longitude and latitude positions to be near each other. If 2 words are very dissimilar or unrelated, we would like them to be far apart in longitude and latitude. And this is the basic concept in the geography of this of this word vector, or this is called word to vec. So this is very difficult to read, but if you look closely at the screen, you will see that every point in this two-dimensional space corresponds to a word, and the words are actually written here. And if you look closely, you will see that words that are nearby each other are related, and words that are far apart are not related. And so the key, and this is a closer look, so this is now zooming in on that prior slide, and so that you can see that there is a relationship or a connection between words based upon their physical proximity. And so this concept of mapping words to vectors is fundamental to how we're going to do the modeling of natural language. So the key thing to think about is that words are not numbers. They're not in the form of numbers. And so whenever we do modeling of language, natural language, that modeling is usually done in terms of algorithms, and those algorithms like to work in terms of numbers. And so therefore what we need to achieve is a mapping of each word mapped to numbers. And then once we have achieved that, we can then do analysis. And so the way that we're going to do this is that we're going to map or relate every word in our vocabulary to a vector, which is like a point in space. However, and to motivate the concept, we thought about two-dimensional space, much as we would think about the longitude and latitude of the globe. But that is purely just conceptual to help one understand it. In practice, we do not limit ourselves to two-dimensional vectors. And so each word is represented by a vector. That vector may be more than 2 dimensions. So in fact, typically is larger than two-dimensional. And the idea is that when words are similar, they should be nearby each other in this vector space. Whenever they are unrelated, they should be far apart from each other in this vector space. Within the context of learning, we are going to learn that the mapping of every word to a vector. So when we talk about natural language processing modeling, one of the key aspects of this is going to be learning the mapping of every word to a vector. And subsequently in our discussions, we will describe many different ways of doing that. There are many ways that that can be achieved. So I underscore that we will learn how to achieve this word to vector mapping. And as I said, this is not restricted to two-dimensional vectors. So usually the vectors will be larger than two-dimensional. So in this discussion, all we wanted to do was to introduce this concept of mapping each word to a vector. And so in the subsequent discussions, we're going to describe how that will be achieved, actually using many of the tools that we already know. But before we get into those technical details, in this lesson, we wanted to first just introduce the concept of mapping words to vectors. And so now as we move forward, we'll see how to achieve that mapping and then how we utilize it in natural language processing.